Dear friends, in this video we are going to see the interpolate function and its functionality. Now here you can see this syntax to use the interpolate function. So data frame dot interpolate, and we have various parameters in this. So in the parentheses you can observe method equal to linear, axis equal to 0, limit equal to none, in place equal to false, limit underscore direction forward, limit underscore area none, downcast none, and arguments. So keyword arguments. So here you can see the various parameters: method, axis, limit, in place, limit direction, limit area, downcast, etc. Now under this method we have various methods to implement this interpolate function. Those are given below in the parameters: linear, time, index, and values, nearest, 0, s linear, and so on. Okay, and each description we have mentioned here, where axis means you can fill it 0 to fill it column by column. Okay, now you can use 1 to fill it row by row. So what do you mean by 0 and 1 here? And to fill column by column and row by row, that means interpolate is a function where you can use is to fill the missing values using some approach. Okay, so and the approaches are the various methods mentioned here: linear, time, index, values, and so on. Okay, now if you want to implement it column by column or row by row, that you can choose using axis. If axis is 0, if axis equal to 0, it means fill it column by column. If axis value equal to 1, fill it by row, right? Limit, you can set the limit maximum number of consecutive NaNs that you can fill. Okay, so you should take positive number, so that means greater than 0. And the limit direction, in which direction you need to check and fill the missing values, so forward, backward, or both. Okay, if you did not mention anything, the default is forward. Similarly, limit area in the data frame, and in place, downcast, keyword arguments, and returns. Okay, so these are the brief description about various parameters that we pass in the interpolate function. Now let's go with some example. Now here, import pandas, and pd.data frame. I have taken a small simple example data frame as keyword arguments. Okay, and here a b c d, and for each I have taken separate set of values. Okay, so here you can observe none values also in each. You can observe none in each. Okay, now if you execute the data frame, if you run it, you can see the data frame clearly. Now this is the data frame what we executed with the previous code, right? Now here NaN means not a number, right? Now we are implementing interpolate function. What is the syntax we told? Data frame dot interpolate. Okay, so here df we have taken here because the data frame we consider df is equal to, so data frame df dot interpolate. And the parameters what we considered, simple one is method we have selected and limit direction we have selected. So method equal to linear, limit direction we have taken forward, right? So let's see this code and execution. Now, if you observe the output, I have selected linear method, okay, and the limit direction is forward. So here, if you observe in the first under under A, under column A, so we have only one NaN value with at index 3. At index 3, we have one NaN value. So that should be filled. So here 12, 4, 5, and NaN value 1. So how this value is filled? Let's see. So it is filled with value 3. So how it is taken? Value 3. So the previous value and the next value it will consider, and it will fill with the middle value considering the previous and the next. So 5 and 1, and the middle value here is 3. Okay, so in that way it fills the values. Now if you observe this second, under this column B, we have two NaN values at index 0 and index 4, right? So which value is filled and which is unable to filled? So let's see with this. What we told in the previous explanation, with the previous value and the next value, it fills that NaN cell. Okay. So now observe the first at index 0, it did not fill anything because it doesn't contain the previous value, and at index 4 it is filled with the value 3, right? It is filled with the value 3, the same value. So you need to understand the when you are predicting the output. Okay, when you have used a linear method and the forward, this will be the output. Similarly, if you check under column C, we have at index 2, this is the value NaN that should be filled. So we have previous value 16 and next value as 3. Okay, so the middle value we should fill with at index 2. Okay, the middle value you need to consider to fill at index 2. So how you have to choose? Here 16 and 3. What would be the middle value? 16 plus 3, 19 by 2, 9.5. So the middle value here, it is 9.5, right? You got it, I think. Similarly, you check this value under column D, 14, 3, NaN, not a number, and 6. So we have two values sequentially. Okay, so at index 2 and index 3. And what about the previous value 3 and the next value 6? So it is easy for us to understand. Now you can say 3 and 6. What are the missing values here? 4, 5, 6. So the output is 3, 4, 5, 6. This is the output in linear method and forward direction. You can try it out by changing the limit direction as backward or both, right? And the method name here we have mentioned linear. You can go with the remaining methods and check the output. Okay, so here time, when you have a data frame with time indexed, I mean time stamped value, right? Time series related value, then you can use the method time. Okay, similarly the other values also you can give a try, and this is the syntax and the method names you can change it, and the axis you can change it, limit value you can change it. Okay, so limit area, limit direction, right? So you can check all these things and implement. So here when I implemented, I have selected only two: method, limit direction. So if you go with minimum these two, you can run the code. Okay, the other parameters also you can give a try, right? Thank you.